Uh, I had not this week. I had not planned to discuss anything technical. I just wanted to give you a good overview and good introduction to the entire course. So, just the last part of the piece today's what I planned was to discuss some successful applications that happened over a period of time in computer vision field, which basically got commercialized and are now being used very widely from in various aspects. I hope people got time and people try in the beginning when in the first class I had sent you the slide also. There also I gave some links for different types of applications, especially the recent applications that are coming up. I hope you got time to browse those links and got some idea. But if you haven't done it, so that's why I put some selection of some successful applications here. But I will go through that quickly because I think much of that will already be known to you. What I want to discuss today, share with you some of our recent projects that we did at VNIT itself in last 2-3 years with my MTech and probably some BTech students, and give you a flavor of how we applied these concepts for addressing problems which we found in our environment, and tell you and show you that it is very exciting things you can actually apply immediately whatever you are learning to do some practical problem solving. So let us move forward from here. Class. Today's class is going to be just a generic class, so nothing much. So here I've just put out some brief history. So although even computer vision was very difficult and the research started probably 1960s only, but even very early as 1970s, some successful applications did start coming up and which started being used in commercial use also. For example, optical character recognition techniques started developing from 1970s onwards. So and then in 1980s, as we have discussed, machine vision and smart cameras started becoming popular. Basically, cameras for factory automation. So there, mostly cameras were used for making the factory production and inspection process more efficient. And in 1990s, in the next decade, basically, more machine vision in manufacturing environment started coming. Biometrics started coming. Medical imaging for medical things started. Medical use started very much. In fact, before pre-1970s, in fact, the space images was being used mainly for space related applications. Basically, people at that time space race was going on, and mostly people cannot go there, so images were captured of different astronomical things and space things, and images were transmitted, and those images were being so the earliest application of image processing was in space and newspaper related industry and all that. In medical imaging in 1990s, medical imaging started gaining popularity because some of the medical imaging modalities were discovered, basically like homography, this brain CT scan and all those things. So those all are based on imaging, X-rays, and all these things are basically kind of an image modeling. We'll be discussing that in our next class itself, how those things are captured. So once those medical image instruments started becoming available, imaging instruments for medical applications, then this application gained very populance in 1990s, and it is still one of the most active popular use of imaging and computer vision. And then recording devices, cameras, surveillance started picking up from 1990s, and it became more in 2000s. In the next decade, basically, we found everywhere in many devices biometrics started coming, better medical imaging, object and face detection algorithms, successful accurate object detection, face detection became available in 2000s. So cameras which can optimally detect faces started becoming available. Object tracking also became kind of a partially solved problem. Automatic tracking of objects could be done, and human computer interaction applications also started coming up in the next decade. And in this decade, it has pervaded everywhere. It is there in autonomous navigation, Google goggles. Social media is one of the most heavy usage of videos and images. There's so much amount of visual information there in social media and Facebook and all places that basically there are a number of applications which can come up there. So I just have some for each of these applications, or at least a sampling of those applications. I've just have one slide here. So this OCR basically was basically used for license plate recognition as well as handwritten digit recognition. So initially the OCR was done mostly for typed text, digital text basically, and that accuracy was achieved earlier itself. But later on, even handwritten digits could be recognized as early as 1970s. So in fact, the first CNN model, this convolutional neural network, which has basically revolutionized machine learning and computer vision. That first CNN model was even developed as early as those by Lee Kun. So it was not 1970s, but I think 1980s, late 1980s something. So he actually developed this CNN, the first convolutional neural network architecture, and applied this for handwritten digit recognition. And they could achieve a very remarkable accuracy. And with that model, they actually used for US. They used for for all the postal delivery, recognizing the pin code number, handwritten pin code number, and automatically sorting the letters mail to different in according to the pin code numbers. So it was mostly used there for that purpose, and also later on it became used for checks, for bank checks, bank checks could be instead of manually submitting it to the bank official, it would get just deposited in an ATM or kiosk, and the machine will automatically recognize the check number and account number and all that, and it will basically do that. So in India, still I think it's not so much popularly being used, but yeah, those things have started coming up. Machine vision is one of the very extensive uses of computer vision. It was especially used for inspection rather than manually inspecting the assembly process, how things are manufacturing, whether there is a defect in a particular piece of the thing being developed. So those things. So basically, the products will be automatically moving on the assembly line, and the cameras, overhead cameras, and all those things will be there. Basically, they will be taking images of the assembled product or the part of the product, and they will be matching it with the ideal part, and basically doing an automatic subtraction and trying to find out if there is something missing or there is some defect, and that would basically automate the process of inspection. And now vision is used for robots which are used for manufacturing purposes. So vision guided robots are being used, and Industry 4 is the most recent technology for factory automation, and this heavily relies on computer vision thing. In fact, there is in our VNIT is going to we have already started Center of Excellence is going to be there on Industry 4, and this year it is going to start officially this Center of Excellence on Industry 4. So Siemens is the company who has basically sponsored that Center of Excellence, and they will be putting all these technologies there, and students who are interested, basically they can basically participate in those projects and all those things. Security and surveillance, I think everybody should be knowing. We see these automated cameras, CCTV cameras there, and black and white cameras were there from long. Nowadays, almost everywhere, wherever you go, you will find CCTV cameras. But mostly those are recorded. Mostly those are being used for passive recording. So after an incident happens, people may use it for forensic purpose. They basically, police people or security people, browse through the videos, those hours on hours of videos, and try to find if there was something suspicious happening in that location during that event, when that event happened. But with computer vision we can automate all those things. Actually, lot of things can be that manual effect, that either a person has to be constantly viewing all those screens, all those multiple camera feeds, but that is very laborious and very error prone. So instead of doing that, if you apply computer vision techniques, they can automatically detect objects which are moving, create their trajectories, and generate summaries of important things that are happening in that location, the snapshots or a short video of a long video. So all those things actually can reduce the effort of surveillance that goes into surveillance and all that. So computer vision techniques are being used for all that, and of course drone and all those are is a very in defense and drone and all those things. Also, this object detection and tracking is being used, and still under development. It's not a solved problem, but yeah, a lot of accuracy has been achieved to some extent, and limited use, specific use of these applications are available. And I hope everybody now, when we use our cameras either from our mobile or through, if you have a handy cam or whatever, we see that as soon as we try to take a capture image scene, the camera generally automatically detects the faces. So the face recognition is inbuilt into our image capturing cameras. So earlier, for example, maybe in 2000, before this object detection and object recognition, face detection came in around 2000, 2002 or 2000. So we see now this in almost all camera. It's a very popular thing, and we'll exactly study what is this technique which is mostly applied, which is mostly embedded in these cameras. So that is basically Voila-Jones face detector algorithm that we'll discuss later on. This was the first traditional. It did not use any heavy duty machine learning or latest machine. It used some kind of machine learning, but not the neural network machine learning. Of course, nowadays we have neural network based face detector, and they are even better than this. And we'll discuss that also in if time permits. Some of the cameras have some utility features also, like if a person blinks his or her eyes, then probably you should take another picture. So if that happens, the camera itself detects that there is a blink in the snapshot. So you can again retake the snapshot and avoid this. Similarly, in Sony cameras, we have a smile shutter. So unless the person smiles, it waits. Even though you may push the button for capturing things, the camera waits for 1 or 2 seconds till there is a smile in the face of the person. So all those are like utility features which greatly enhance the utility of the devices. And then there are biometrics. Everybody knows the fingerprints and face recognition and all those things, iris recognition. All this actually involves computer vision and image processing, and they are there in almost all systems, not only for system access but premises access. If you go within a premise in a building, there will be these systems installed which will authenticate whether the person is a genuine person or is a stranger. Or object recognition also has come in recent past. So, for example, you can even when the smartphones were not there, even we were with our basic cameras when they were Nokia and all those cameras, you can actually, these applications had started coming at that time itself. You can take a camera if you are visiting a new place and looking at a location. You can basically take a snapshot of that image, and you can use that application. That application will basically recognize whether if it is a specific monument or a specific building or a specific unique sculpture and whatever. It will try to search from the images on the web, and will give you the exact Wikipedia page of what that structure or what that thing is all about, and you can basically get more information about that location or that building or whatever. This human-computer interaction interfaces became very popular with Kinect device. So Microsoft released one depth sensor, which was called basically a Kinect sensor. It was not only having an RGB video, but it also captured the depth video. So depth video, where basically the image looks like this. So the front one and the depending on the how far the object is from the camera, the intensity of the pixels is varied. So using this depth information as well as RGB informations, they could accurately track the skeleton without any heavy machine learning things. So skeleton tracking could become very fast and real time using this depth, accurate depth and RGB thing. And then once skeleton could be detected, then the gestures and all those things could be very easily recognized. So this Kinect basically revolutionized the gaming systems, the Xbox and Sony PlayStation and all those things. They use these kinds of devices for for more intuitive and natural game playing operation. So so I think I'll briefly script these things. So smart camera, these are now the most of one of the latest application of computer vision is for smart cars and autonomous navigation. So these high-end automobile manufacturers like BMW, General Motors, and Volvo, they were basically equipping their high-end models with cameras, side cameras, back rear-looking cameras, front-looking cameras. So for full safety of the car as well as the as well as the pedestrians. So if the car is going backwards, if you are taking a back, then the camera will see whether there is any obstacle or any person or any child playing behind. So it will immediately take a break or alarm the driver. Similarly, forward-looking cameras will also see the obstacles, and similarly, if you are opening the door, the side-looking cameras will see whether there is something coming from the side and all that. So all those things will be there for giving warning whether there is going to be a collision with any pedestrian, if the vehicle is going to depart from the lane, and so on. So all those kinds of intelligent warning systems could be built within the car itself using multiple cameras. Of course, this is a more ambitious project, autonomous cars. Still, it's already some places they have already approved and they are working, and they 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 are not only relying on computer vision but many other types of sensory information they use. But many of these do include lidar cameras and vision cameras also. And using a combination of those multiple cameras and sensors, they're basically trying to do autonomous driving. And you must have read the news of all those things. So what is the current state of the art? Can computer match or beat human vision? So as we have already talked about, it's an AI complete problem. It's not going to happen in any time near future. So it is mostly no. Answer is mostly no. But for very specific application, for very in a specific environment, once you constrain your problem, once you constrain your environment, then definitely a customized solution is possible, which can work with a remarkable accuracy, which is acceptable in real time scenario. So humans are much better at hard things. We can recognize very hard things. Even if a image has been faked or it has been morphed, we will be able to understand. Okay, this is probably a false image or a false thing. But computers cannot do those things. Computers are good at easy things, so things which are more, as I said, once you constrain and make your problem simpler, then you can actually do a good job with computer vision. But otherwise, it's little hard. A general AI solution is very difficult. So, but still, with machine and deep learning techniques, we are still increasing the performance day by day. So every month or every now and then, new papers are being published, and which are basically beating the old results and excelling them. So now I'll come to our projects at VNIT, and once we come to automated attendance, I'll ask Tanush to speak on that. So I'll just tell you some of the selected projects that we have done in computer vision in VNIT itself in last 2, 3, 4 years. So one of the first project that I started I joined VNIT 3.5, 4 years back. First project I started was this. We basically tried to develop a vision-based proactive security guard for bank ATMs. So this was mainly done because at that time we found there were many news coming about ATM thefts and all that, rise in ATM thefts and so on. So basically we try to normally there are normal CCTV cameras are there, but as I said, they are mostly used for passive recording. Only when the event does happen or something has already happened, then people can use those cameras for forensic and investigation purpose. But what we wanted a proactive prevention rather than passive recording. So in real time, system can actually try to understand if there is some an abnormal action happening or something which is not allowed in ATM. Can we detect that? And so the aim was to minimize first of all manpower cost, so there need not to be a security guard there, which always 24/7 hours. And even if and we can summarize, and so even if it is used for forensic investigation, you don't have to manually search through every second of the video. We can create a summary of the video, and that can be much less labor intensive of job. And to improve the accuracy, we actually use this Kinect or the depth sensors, which actually gave us these three data modality. So these three data modality, I have a video here. If you, we basically, this is my cabin in the office. Put this camera there and just mimic an ATM kind of event here. So this sensor gives us these three modality: normal RGB video, this is a depth video, and this is the skeleton video, which is extracted using this RGB and the depth information. So using these three data modality, we could achieve a remarkable accuracy in doing our detection. So here I have a demo video of this. I will not play the entire demo. Oh, sorry. I think because anyhow, sound, there's a background sound about thing, but so here the person is entering. Oh. Sorry. So for example, if a person tries to bend down, the system detects that it is bending down. If it tries to cover the camera, it detects that he is trying to cover the camera. Generally, mask or helmet and all those things are not allowed into an ATM. So a system will detect that this person is wearing a mask. So it will basically proactively ask the user to remove the mask and so on. If there are multiple person entering, normally only one person is allowed, but if multi-person enters in an ATM, then it also can give a warning that please one person go out, only one person is allowed at a time, and so on. So these kinds of simple heuristics, and then even more complex things, like there is a fighting going on, or if a person is basically trying to vandalize the ATM, basically tries to, so if you're doing a normal activity, it's okay, it doesn't say anything. But this is a scenario for suspicious, where a person is just not trying to not trying to transact on ATM, but just roaming around in the premise, in the ATM premises, or just doing some kind of an abnormal action. So the system detects that it is not a normal activity pattern, it is a suspicious action. And if you bring some rod or something for vandalizing the ATM, it detects those objects also, and proactively gives an alert saying that this is an abnormal thing that is happening here. So all those things are there. Later on, if you can see that. So that was one of the things. We have filed a patent on that, and we are still improving upon it. Things. This is the another thing that we tried, camera based on online classroom attendance management system. So nowadays we have an intake of 140 in our BTech. So we have a very heavy classroom, and taking attendance and all that would take more than 10 minutes and all that. So we try to use basically a cheap solution by which we can actually take automated attendance and using camera. So we use a low resolution fisheye panoramic camera and fit it on the ceiling on the. So we took a top view of the. So instead of face recognition, because face recognition accuracy is little bit problematic, and then faces get occluded in a classroom. So we went for a top view solution. So we basically, because generally students like to sit at, they have their cozy spots, so they sit at particular locations. So we fixed those seats of different students, and then we basically just detected whether at that particular seat the student was present or not. So it does not require any active participation from student. Student doesn't have to do anything. Teacher doesn't have to do anything. And during the scheduled slot, the system will automatically see whether that seat is being occupied by a person or not. If the seat is being occupied by a person, then we'll mark attendance. Otherwise, if there is a bag or if there is a book or if there is any other object, or if there is empty seat, it will be marked as an absent. We don't need to store any biometric information, so there is no personal privacy leakage. Also, we don't have to update biometrics every year for every batch of the students. So all those benefits of the systems were there, and of course we created a web portal for this so that cumulative statistics and report could be generated. So I think I have a video here. So it's basically a portal which we have developed and which we used for our 1 or 2 semesters we have used, but after this lockdown we have not used because there is no physical classroom. So faculty can log in and take attendance basically. So this is manually if they want to take attendance, but even if they don't have to take manually attendance, the scheduling, automatic scheduling is also possible. So during the destined class slot, the system will automatically take so it will start and stop the attendance, and all the recorded sessions all the stats will be there. So it can basically process the attendance. So once it processes, we basically get this kind of an output. I'll show the output in more detail later on. So we can see the seat numbers and the location numbers have been detected. So whoever the students are present, they are marked as green, and wherever they are absent, they are marked as white, and so on. So this is another thing that we have basically tried. So after the attendance, after we were able to take the attendance, we basically what we did was we also tried to go one more step forward. Since anyhow we are having cameras, but we have actually smart classrooms also in our department where there are cameras already installed for recording purpose and other purpose. So we started saying, and that can we use it for basically estimating the attention of the student, how much attention span students are having, how much how engaging the lecture is for our feedback itself. So because many times when there is a heavy classroom, we don't even get to see the students whether they are paying attention or they are able to they are being actively engaged or they are feeling boredom and all that, because we are mostly worried about writing on the blackboard or delivering our lecture. So we try to bring a vision-based analytics in the classroom to automatically do all that thing. So using here are just some sample images of the people, and you could actually detect these whether students are feeling sleepy or they are being distracted or whether they are using mobiles, and because that is a very common problem now. A student has to sit in same place every day to take attendance. Yeah, for the attendance system, yeah, for this attendance system, student has to sit at that same place, because what we found actually already students were sitting at the similar place, because people have a group, and generally one group liked to sit near the window, some group like to sit in the front, some group like to sit at the back. So we thought anyhow they are sitting in the same place mostly, let us fix it. And that would not be for the entire class. They don't have to sit at the same place during the time of attendance. So if the teacher is manually taking attendance, just he will say now I'm going to take attendance. So mostly students either will be sitting in the same place or just nearby, so they will just quickly rearrange in a second, and then I will take start and stop. I'll do the start and stop period through the app, and they will take attendance. So it's not compulsory to sit for the entire class. Yeah, but this system requires that. If you have to remove that, then you have to go for face recognition, and we will try. We are also working on that also to try to have good face recognition performance also. So we'll see that. But right now, at least instead of face recognition, we are just doing an emotion recognition and active. So we are trying to do. We have basically considered some student learning based emotions like sleepy, boredom, yawning, frustrated, confused, engaged, and so on. And we try to basically use a face detection algorithm to capture the faces in a real life in a ongoing video class, and then from those faces, with each face emotion we characterize into one of these 5 levels of engagement, and then we basically draw an overall statistics of as time progresses, as the lecture is progressing, how the engagement level is going, whether it is increasing, decreasing. So, and this can be a real-time feedback for the teacher. student teacher, if he finds the students are now feeling bored, he can basically adjust the bring or this do some pedagogy change so that people can be more actively engaged. Or if not during the class, at least after the class happens, student and the teacher can actually get the feedback of the entire class and improve the lecture delivery in the next class and so on. So this is the mini project that we gave last 2 years in this course itself. This was the last. This was an assignment or the mini project that we gave during this course. So we basically generally in our institute still a manual feedback mechanism is there. So generally feedback to this is going. Student feedback happens every time using this. There is a manual sheet which is given, and then our staff, our department staff basically feeds these values manually into the system and then calculate the overall score that each teacher has been students are given to teachers and all that. And that is done because online there is no privacy and all that. There are leak, so that's why we go still do manual feedback form, and we wanted to automate this thing. Similarly, in our this is an answer script snapshot. This midterm and end term exams answer scripts. So generally after your mark sheet is evaluated, we fill your marks for each question and the total marks, and then these marks are being used for course outcome analysis. So we are our program is NBA accredited. So NBA accreditation requires one thing, that every evaluation we have to basically correlate with how much. So every course has some course outcomes. So I defined some course outcomes for my course. So now questions should be asked based on those course outcomes. So every question should be meant to achieve that course outcome. So now based on how well students are performing in each questions, we can get a quantitative estimation of how much outcomes we are able to achieve through this course. And that is a mandatory requirement from NBA that every faculty should do it. But it's a very labor-intensive task. Nobody does it. And somehow when NBA inspection team comes, people just fudge around and do things. So we try to automate it. Can we automatically must, because anyhow we have these answer scripts. We take a snapshot of this thing, and from this table we can automatically extract that question number 2 the student has got full 5 marks, or question number 2A he has got 4 marks, question number 2B has got 1 mark. So using this tabular data, we can automatically extract we can automatically get it into Excel sheet. And once this data is already in the Excel sheet, then doing that course outcome analysis becomes as easy as just simple Excel operations in simple Excel things. So, and we gave this mini project to the students itself who took my course. And last year, I think many of the groups have achieved more than 90% accuracy in detecting as well as recognizing the digits. So recognizing, still we are not having full. For detection, people have got 100% accuracy, but for recognition of these numbers, sometimes if the numbers are not written properly, the digit recognition is not fully accurate. So still we are working on it to improve upon it. But these are some applications we just developed. We found some problem which were manually intensive, and we basically try to automate using the application of computer vision. So remaining, we don't have a lot of time. So this was an application that we did in Nagpur. We have a smart city Nagpur program. So our Nagpur is a smart city. Was identified as a smart city of under the government plan. So generally in Nagpur, all intersections have been installed with traffic cameras, and those traffic cameras are recording the feeds and all that. But again, there are no applications to use those things. So we try to pitch in and try to basically try to develop an intelligent traffic signal time management. So depending on, rather than having a static fixed time for each side of the signal, depending on the concentration of vehicles in each side of the lane, we can actually adjust the traffic signal. So basically we tried to capture we took some video feeds from those traffic signal people, and then try to run our vehicle detection and object detection algorithms and classify the objects also, the vehicles. So depending on what type of vehicles are there and how many of them are there, we basically we could adjust the signal time also. That possibility is there. It could not successfully be done because the student was not so active in this project. So this is another application which my BTech students have actually worked on traffic surveillance, but we are running short of time. So basically we try to do wrong way driver detection and stop vehicle detection. So again we use the traffic surveillance videos for this purpose. And this is the recent news, last just 1 month before the Smart India Hackathon, which happened last in this year. My BTech project student team actually won this Smart India Hackathon for this project, where they basically use it for Indian number plate license number plate detection and extraction. So this, our team got the best accuracy from all over India, and this project was guided by me. And there is a YouTube link. You can just when I share this thing, you can actually go. You will see this their demonstration. So it works even in the night time. You can see this basically detects the number plate even in the night time, and they have basically developed a lot of apps and all those statistics and all those things. And it basically detects the number plate, the accuracy, and so on. So this is the demo of their things. I have actually put the YouTube link of this their demo there. And this just what application I have covered is just a sampling, and most of these applications are very recent, and many companies who are working this, their shares have increased. For example, Nvidia has grown in last 10 years. Nvidia has become, from starting from a very small company, it has become one of the giant company, matching with Intel and other things. In fact, he has recently Nvidia has actually has, I think, purchased AMD or ARM ARM, this ARM processor company. And these are very big companies which work actively in computer vision, and they hire people in computer vision and all those things. And many startups you can see in India also, many startups which have become well established. These are actually computer vision based startups and so on. So I hope we have given sufficient appetized your hunger for this course and all that. And next class we start working on the details.